All right, so this is going to be a video on factoring by greatest common factor. But again, to understand factoring by greatest common factor, you need to understand where it comes from, what we're looking to do. So in other words, factoring by greatest common factor starts with understanding what you're supposed to be creating. So let's just take a little warm up. I have 4 examples, and they'll get harder in complexity as we move forward. So for this example, in number 1, okay, everybody knows, I think for the most part, this is called the distributive property, okay? But what gets lost in translation here is that the distributive property is a property through multiplication, okay? And when you multiply things, okay, the things that you are multiplying are what we call factors, okay? So in this problem, what I have, if we take a look at these, so I'm going to jump into number 1 here, okay? In red, I have a factor of A, because factors are anything separated by multiplication. So when you put a variable outside of a parenthesis, it becomes multiplication. So there's separation. So factor 1, okay, so you have factors of A, and then you have factors of the other one is 3a plus 7. So now why one of these is called a monomial, it's just one term, okay? The other one here is a linear binomial, right? The degree of this exponent is 1, all right, and it's 2 terms. So with all that being said, okay, your factors are the things that you're multiplying together. Now, when you multiply them together, all right, this becomes what is known as the product. All right, so this is what's going to be important. So the product. So if I take A and multiply it by 3a, it no longer is just 3a, it becomes 3a squared. Okay, and if I take this a and I distribute it to the 7, this now becomes positive 7a. So what I've done here, all right, is I've distributed a factor of a to the 2 terms on the interior. Now what happens if you notice, okay, the 3a turns into 3a squared, and this 7 turns into 7a here. So essentially what I did is I gave this 7 an a, and I gave this 3a an additional a. Okay, so basically what we're going to use the terminology is we're going to say, well, what do they share in common? So you have to understand that this 3a squared was created by sharing an a to 3a and sharing an a to 7. So the goal to figure out here is after you have the product, you're then going to look at each individual terms and you're going to say, okay, what do they share? And also you're going to need to tell me how many. So in this case, the 3 and the 7, they shared nothing. Okay, 3 and 7 have no factors in common, which means you can't divide 3 by something you could divide 7 by. However, the a squared and the a share something in common. However, a lot of people want to say that they share 2 of them. They don't share 2, and that goes back to this problem. Okay, a squared was created by giving a an additional a to make 2, and giving this one that had none just 1. So what these 2 terms share is this value of a, because that's what sort of the distributive property is. It's sharing amongst terms your variable. So that's just important stuff to understand. And when I start using these things of like, what do they share in common? What could you divide by? That's the type of thing. All right. So going a little bit forward, increasing this warm up to make it a little bit more challenging. So again, in this case, it wants me to distribute a 2. Okay. So my factors, so if I write this over here, right now my factors are 2 and 5m plus 3. So if I multiply 2 times 5m, that equals, okay, underneath my product section here is 10m, and 2 times positive 3 is positive 6. Now, looking at this one, okay, so if we go over to the product here, well, what do 10 and 6 share in common? Well, the reason 10 and 6 share something in common is because notice 10 was created by multiplying 2 and 5 together. 6 was created by taking the 3 and multiplying it by that identical 2. So when your teacher says, what are they divisible by? What is the largest thing you can divide both terms by, right? So that's kind of what we're looking at. What could you divide this 10 by that you could divide 6 by? And that terminology, okay, comes from this is the product. When we do factoring, we're actually going to try to get back to this expression here to make up what was the thing that got distributed. All right, so let's make this a little harder so it's a little bit more complicated. All right, so going on to the next example. The next example just has a number and a variable. All right, so continuing on with this particular example, okay, my factors. What are my factors? My factors are 3b, and then my other factor is 2x squared plus 3x plus 1. So what I'm going to do is I'm going to distribute it. And when I distribute it, okay, the product, okay, becomes, so the answer to a multiplication becomes, so I do the 3b times 2x squared, and I get 6, and then multiply the variables. B times x squared is bx squared. And then I multiply the next term, so I distribute again, which is 3b times 3x, which is positive 9, and that will be bx. And then I multiply the last term, which is a positive 1, so anything times 1 will inevitably be itself, so this is plus 3b. So again, just taking a look at this, the goal of being able to factor by GCF will be able to look at these terms here and see what is it that they have in common. So the first step you look at is kind of the numbers here now that we have numbers. So 6, 9, and 3. Okay, to think about going back to a multiplication problem, we actually think about division. What could you divide 6 by, 9 by, and 3 by? And that value is 3. So if you notice over here, 3 times 2 made the 6, 3 times 3 made the 9, and 3 times 1 makes the 3 over here. So the next thing that you have is notice that each one of these terms has a b, okay? But notice they don't all have x's. And you can tell, right, in this problem, I made it up. Notice I did not distribute an x. So what you are looking for is what each individual term, all collectively, each term shares. And in this case, we shared a 3b to each term. So when we go to factoring, we're going to look at this and just go the opposite way. So on the last one, to make this as complicated as I possibly can, we're going to distribute something with variables, multiple variables and a number. So here we go. 3a squared b times 5ac. So take it one step at a time. 3 and 5 make 15. A squared and a make a to the third. B times no other b's make it a b. And then you still have a c there. Okay. So on to the next one. So we're going to distribute that same exact thing going over. So plus 3 times 2 is 6. A squared times a is a cubed. And b times b squared. So this b times this b squared is b cubed. And then on to the last one. So 3 times negative 6 is negative 18. And then a squared. So a squared times a squared is a to the fourth. So notice, knowing your multiplication properties of variables is important. So notice I'm actually multiplying the coefficients, and when I multiply the variables, I'm adding their exponents. So again, keep that in mind. So last step, b times b is b squared. So if you look at all of these terms, when we get into factoring, okay, we're going to be looking at, okay, the way that most people like to think of this, what could you divide all of these variables by? And then division, okay, we're not just going to simply divide it out. What we're going to do is we're going to write it as a factor. So our divisor is going to be made into a new factor. Okay, so let's get into some factoring here because we've spent 9 minutes trying to explain where it comes from. So let's go ahead and get into it. All right, so factoring by GCF. So what we want to do is we want to create factors. So when factoring by GCF, what you're going to do is you're always going to have this turn into some monomial, okay, multiplied by some polynomial. That's what it means. So what you are looking for is you are looking for one term okay, that you could divide from everything. And then you're going to write it as a multiplication by a polynomial. So if I set this up into factors, I will have my monomial out here multiplying, okay, my polynomial. So in this case, all right, notice I have two terms. So that means this polynomial that I have over here must have two terms in it, okay? So what I'm looking for is what one single thing, okay, it could be a collection of terms, but what one monomial can I divide out of these two? So the first thing we do is we always look at the numbers. So what number does 15 and 10 share in common through division? So meaning if you could divide 15 to get a whole number and 10 to get a whole number as your answer, what could you divide by? So in this case, you can divide by 5, okay? Now, you also at this point, because we're talking about greatest common factor, want to always make sure you're dividing by the largest possible number, okay? So in this case, I will start off with what my divisor is becomes my factor of the monomial. So this is the beginning. So I write a 5. The next thing I have to look at is the variables. So this has an x, this does not. So they do not share any common variables. So the next step I will do is I will write, okay, there's two ways to do this. You could do your 15 divided by 5 and you get 3x, and then you can do your 10 divided by 5 and you get positive 2. So that's one process to go through here. But now my answer is in factored form, because what does it mean to be factored? To be a factor means to have things that are multiplied together. So there we go. I have my factors. So to factor by GCF means to divide what one common number, what one common monomial can you take away from all your terms. Okay? So again, let's go on to the next example, number 2. So if I were to divide away something from here and here, okay, what would that value be? So I'm going to move over here and I'm going to set up my thing. So notice my original polynomial has two terms. So I'm just going to put a line here. You don't have to put a line. I'm just doing it to set it up. So I have my blank spot, and then my polynomial will have two terms left on the inside. So what I'm looking to write here, okay, in this spot, is one monomial that I could divide away from these two beginning terms. So the first thing I always look at are the numbers. So these numbers here, okay, 3 and 12, I can divide both of those by 3, all right? The next thing that I'm going to look at is, are there any variables in common? So this is a group of x squared y, and this is a group of just y's. So that means down below with my 3, what I'm going to write is I'm going to write what do they have in common? How many things do they equally have? And they equally have, at most, one y. They don't both have x's, so I can't write an x down there. So I'm just recording down here what they share in common. So now my divisor here is what we write as my factor. So this is my factor. My factor is the monomial of 3y. And then from here, what I'm going to do is I'm going to go through the process. Okay, sorry, let me get rid of that circle and stuff. So I'm going to go through the process of actually doing this division. All right, so that means what I'm going to do is I'm going to take the 3 divided by 3, and that's a 1. The x squared can't be divided by anything, so it's x squared, and y divided by itself is nothing. So it's a 1. I shouldn't say it's nothing. It's a 1, but I'm not going to write another 1 if I already have one. The next thing I'm going to do, okay, is I'm going to take 12 divided by 3, and that is positive 4. And then I will take the y divided by y. So if you really wanted to, you could write a times 1 here, but that's pointless, right? So you don't really want to do that because 4 times 1 is just itself. So more commonly, the way you'll see this answer, this is done. The way you'll see this answer is written as 3y times x squared plus 4. And at this point, you will have completed factoring by GCF. So now the goal is to not have to eventually show all of this work that I'm doing. The goal is to be able to look at it and write what I'm writing here to directly just write it over here immediately. Okay, so that is your goal to achieve. So let's go on to the next example and I'll show what I mean by that, to what you want to achieve. So on to my next example. All right, I have 8x cubed plus 2x squared plus 10x. So what I'm looking at between all three of these terms is what can I divide each of these by. So as opposed to writing it here, okay, so as opposed to writing it in this spot, okay, instead of writing it down here beneath, what I'm going to do is I'm just going to go directly into the factored form. All right, so going right to the factored form. So I'm looking at the 8, the 2, and the 10, which means I can divide them all by 2. So going directly into factored form, I start with my 2. All right. Now, the other thing I want to notice here is that I'm going to have one term out front, and then I'm going to have 3 terms this time. Okay, so instead of just having 2, I will have 3 terms in the middle here. So I'm just going to give myself a little extra space when I set up so I can write 3 things here as opposed to 2 in the first example. So first thing I notice is the numbers can all be divided by 2. And the next thing I notice is that this has 3 x's, this has 2 x's, this has 1 x. So the question is how many do they all have? Okay, so how many do they all share? All right, and if you notice, okay, they don't all share 3 because this one has 2 and this one has 1. So inevitably, they can only ever share the amount that the whatever term has the least of. Okay, so in this case, the last term only has 1x, so they can only at most share 1. Even though this has 2 and even though this has 3, they can only at most share 1. So I write 2x. And then from here, it's going to be a matter of rewriting the problem. So now I do in my head 8 divided by 2. So 8 divided by 2 is 4. All right, I did have 3, but it was because it was shared with 1. So that means to turn 3 shared with 1, it means that it had 2 to start with. Okay, and then I'm going to go on to the next term, which is plus 2. Okay, and I take the 2 divided by the 2, and I get positive 1. And I had 2 x's in the end, and it was shared with originally 1. So to get 2 by sharing with 1 means you have started with 1x. And the last term is 10 divided by 2, which is 5. And to have 1x in the end, and it was shared with 1, it meant that it had none to begin with. Okay, so my final answer to this problem in GCF factored form, okay, so GCF you need to know is a monomial, so you're only ever removing a monomial from a polynomial, and then you're going to have a new group of terms that gets created. All right. So that's GCF. So that's the shortcut. That's what you want to attain to do. All right. But I'm not going to do that on the last one because sometimes it's actually helpful to write it as the other expression. So here we go. All 3 of these terms. So the first thing I'm going to do is I'm going to set up my answer. Okay. So my answer is going to have a monomial out front. So I know that for GCF, always a monomial. And then I'm going to put my parentheses, okay, for this work. So what can I divide all of these things by? Now, for the numbers, okay, we can actually just think about the numbers. What can you divide 3 by? That 9 can also be divided by, that 15 can also be divided by. And you just want to make sure that you're choosing the largest possible number. Now, for these examples, I didn't really choose massively large numbers, but the largest thing that all of these can be divided by is 3. So there's 3. And then the next thing I want to write is, okay, how many variables do they all share? So starting off just alphabetical with A's. So A's, that has 3, that has 2, that has 1. And remember what I talked about before, they can only share the least amount that all of them have. Okay, so if they don't all share something, then they can't all have something. So in this case, the least amount of A's that one of these terms have is just 1. So this has 1A, so I'm just writing this down here, okay? And the next thing I look for is then I'm just going to go alphabetically. I'll go to the B's. So this has 2, this has 3, and this has 4. So again, all right, what's the most amount that they all can share? They collectively all have. So they all have at least 2 B's. So I write that as B squared. And then the last thing I move on to is the other variable, which is going to be, let me get a different color here. I'll write this in pink, which is C's. Okay, so the C's. So the C's all have, so this one is 1, this one is 2, and this one is 3. So they can all at least have one C in their grouping. So remember what we do is we take this, okay? So notice this all matches. So there's our common divisor, which becomes now, we don't just get rid of it, it becomes our factor. So this is 3ab squared c. And then what we're going to do is going to go through the process. So what is 3 divided by 3? It's 1, okay? 3, when you shared the 1 away, which means you divided it out, means 3 take away 1 is 2, okay? 2 take away 2, you don't have any. 1, okay, take away 1, you don't have any. So the first term is just going to be this 1a squared. Moving on to the next group of terms. So, the next term, which is 9, negative 9 divided by 3, which is negative 3. And then 2, take away 1 of the a's is, you're left with 1a. Okay, 3 b's, take away 2, means you have 1 b left. And then the c's, 2, take away 1, means you have 1 c left. And then moving on to the last term, 15 divided by 3 is positive 5. 1 take away 1 is none. 4 take away 2 for the b's means I'm left with 2 b's. And 3 take away 1 means I have 2 c's left. And now what you're left with is a factored expression by GCF. So what you need to remember, if someone says to factor something by GCF, you're looking for what monomial, all right, can you divide out of each term? So the numbers, you can actually think of division, but the variables, all right, you have to think about what's the most that each one of them share in common. All right, so I hope that helps, but that's the hardest example I got for you for this one. So that is factoring by GCF. Let me know what you think and if you need anything else.